Hello, in this video we are going to see NoSQL databases with focus on MongoDB. We'll see the MongoDB in detail with Mongo shell. We'll run some commands to create a DB, run some other commands to insert documents into the MongoDB, update, delete, and do manipulations with them. Let's get started. These are the topics which we'll be seeing in this video: relational versus non-relational DB, types of NoSQL DBs, MongoDB details, and MongoDB manipulation using Mongo shell. The thing is the data structure. The relational databases have a normalized data containing rows and columns. The data is in the tables. We have relations between tables, and the data is normalized. In case of NoSQL databases, we sacrifice normalization for optimization for performance and scale. And we have different kinds of data models which are possible: key value, document, graph, etc. The schema in case of relational data is fixed, meaning that you know that what would be the columns in the database, what would be the relations between different tables, if there is any foreign key by which the table are related by referential integrity. All those things you should be having fixed in case of relational database. But in case of non-relational database, it's a flexible schema. You define a set of data elements, and then you can extend the set of data elements later. There is a flexibility of data elements in the store, on the non-relational store. For querying in case of relational database, we use SQL query language. Here it is a database specific or custom query language. There are relationships between data elements in case of relational database, which are established using foreign keys and joins. And this is a denormalized structure, so there is not much relation between tables, and that is not typically used also because they are meant for performance. They are denormalized data storage. When we talk about scaling, so in case of relational database, it's a vertical scaling. What is the meaning of vertical scaling? Vertical scaling basically means that you would be enhancing the compute facilities of a system, be it with respect to hard disk drive, be it respect to the processing power, RAM, etc. You will be upscaling the same infrastructure and increasing the details of that specific thing vertically. But in case of non-relational database, it is a horizontal scaling. We do something called as a sharding. And sharding is like, for example, we could have a hash based algorithm wherein some data is stored in one node versus another data stored in another node, and there could be replication also. So data is distributed across servers in case of non-relational databases. This is a typical, I mean, in case of relational also you can have sharding, but typically this is what is being done. Use cases, we have already seen the use cases of relational database, which are like complex queries, structured data, data integrity is critical. In case of non-relational database, we have flexible and scalable data, which is unstructured or semi-structured, less emphasis on the data integrity. Another thing to note for the relational and non-relational database is this. So a relational database subscribes to these properties, which are also called ACID, atomicity. Atomicity means that everything is treated as a single individual unit of work. So a transaction is either complete, in full, or incomplete. That means there is never an unstable state where some of the part of a row is affected and some part of the row is not affected. If we are updating a row, everything which is there in the update statement would be updated, and partial updates won't be there. So that is what is atomicity. Then we have consistency. Consistency ensures that a transaction brings the database from one consistent state to another inconsistent state. So, uh, so if a transaction violates this thing, then the database is rolled back and the database remains unchanged. So which means that there is a consistent database view in case of relational database. Then we talk about isolation. So isolation guarantees that concurrent transactions do not interfere with each other. So if you are doing two transactions at the same time, they should be complete in their entirety. They should not be disrupting anything which is happening in another transaction. So one transaction is separate from another transaction, and thereby they are isolated. Each transaction should be executed as if it was the only transaction in the system, and the intermediate states of the transaction should remain hidden from other transactions unless the transaction is committed. Durability. So durability ensures that the data that is once committed will remain permanent and will survive any subsequent failures which are there in the system. So this is the properties of a relational database. In case of the non-relational database, we call something as a base, the properties of the database as a base. So basically available. So rather than enforcing a immediate consistency, NoSQL database will ensure availability of data by spreading and replicating it across the nodes of the database cluster. What this means is that they would be available, uh, but there may be cases where it may not be immediately consistent. It may be consistent after a while. Soft state. So because there is a lack of immediate consistency, data values may change over time. So that is what is a soft state. Eventually consistent. So because this is meant for scale, the non-SQL database, NoSQL database is meant for performance scale. There can be cases where there may not be immediate consistency, but eventually it will be consistent. So let's say that there are multiple nodes which are replicating the data, and you write something here, and if you fetch read it from this node, that that effect has not taken place here yet. So you may be reading a stale data. Okay, read is done from here and write is done in the another node, which are replicating nodes. Then what is happening is, because the write happened first and the read happened later, but the data has not been consolidated yet, you are still reading stale data. But this does not mean that it will always be the case. After a time, eventually the replication will trigger, and eventually will be in a eventual consistent state, which means this and this would reflect the same data. So that is what is meaning of eventual consistency. So these are some of the examples of our NoSQL database type. I will not read them in detail, but we can understand. For document store, we have MongoDB, key value, we have Redis, column, we have Cassandra, we have graph database like Neptune, we have wide column stores like Cassandra. So all these databases are there. Another important thing which we typically use is S3 or cloud storage, Google Cloud Storage, Azure Blob Storage, etc. So this is the page where all these things which I'm going to demonstrate now are listed. We have already seen the different kinds of relational and non-relational database properties. It's also listed here. The kind of DB stores which are possible or which are available, they are also listed here. The focus of this specific part of the video is to see some Mongo shell commands. So let's start from here. Very simple. Help would display the help information. Show DBs will list all the databases which are available. Use DB, if you do, then it will switch to that specific database. And if the database is not available, it will create that specific DB. So this is for meant for creation of a DB as well. Then if we want to insert something on the DB, we say db.collection, and this collection, whatever the name which we are giving for the collection, this collection will be created if the collection is not present already. And insert one will insert one row or one item inside the collection. So let's see this in action now. So I have MongoDB Compass open here, and what I'll do is I'll connect to my MongoDB now. Once it is connected, I'll open the Mongo shell by clicking here. So let's start from here. Use DB, we said. So what I'll do is use Jiffy DB. So it has created, there was no DB by the name JiffyDB. It created a DB by the name JiffyDB. Now what I'll do is, so you know that there is no collection because this is a empty DB. So what I'll do now is I will create a collection here by the name my collection and insert something here. So it has inserted that detail inside this collection. And if I do this command, okay, so if I say, so whatever was listed that has been found because only one element was there, only one has been found. And if I say that I want to do a find based on this criteria where I say age is greater than 25, again it will find the same thing. Yeah, because this is greater than 25. Let me quickly do one more thing. Let me create one more record and let me call it so I have, when I say greater than 25, still one is, if one record is being displayed because only one record is greater than 25. If instead of 25 I would have made it 20, then the two records shall be displayed. Okay, because both of them are more than 20. Now let's go ahead. You want to update something, you can call this where the name is John, set the age to 31. So this is the update. So I'll just do it. Okay, it has modified one count, and if you see now, so the age has been updated to 31. And same thing, we can delete it. If I run this, it will delete this. So let me run it. So this is deleted. Now if I do db.mycollection.find again, it will have only one thing because the other one has been deleted. Okay, and you can aggregate them with the help of age. You can create indexes here. If you want to get the schema, this is little important, so let's see this. If you want to get the schema, what you can do is, so this is the thing, and the second line I'll just copy from here to avoid typing. So I can see that this is the different items which are there: ID, name, age, email. Okay, but because this is going to find any of one of them, it is not finding the one with the most comprehensive schema. It is possible that some of the schema items may be missing. Let me show that with an example. So what I'll do is I'll create the John again. I'll copy from here and I'll paste it here. And what I'll do is, after email, let's say address, and let's say uh, May Street, US. Okay, so this is the address, and then I press a enter. Now you see that this schema and the other schema which was there earlier does not match, which means if I do db.mycollection.find, this elements has a different schema than this one. So we don't have a fixed schema here in the NoSQL, and that's what we see here. Then this is the detail of query. In case of query, you can have a query and you can have a projection. Projection essentially means that which field you want to include or exclude from the result. So here this is example of projection. So if you want to include name, you put a 1, age 1, email and address you don't want to include, so you are putting 00 there. So let's see that we have to include only the name and age. Then what we shall be doing here is we shall be running this. So what we will be doing is we shall be running what is required with the help of those two parameters. So this is the projection, and we are now getting only the name and age. So that is projection in case of query, and we have seen query some other examples. So that's what is the conclusion of this small video on MongoDB and NoSQL databases. Thank you very much.